Hello everyone, welcome back to my YouTube channel. Today we are going to talk about EAD exposure at default model. Okay, and we would be building the model in SAS. So before we go to the SAS code, first of all, it's important to understand the data. So let me open the data, and this data you all will be able to download. I will give you the link for the GitHub repository where I will paste this data. And on that note, first of all, again, welcome to all of you who are very new on my channel. So guys, before we jump obviously into the code, I open this particular data. So let's quickly talk about the inputs. Okay. So for your exposure at default model, we need loan level portfolio data containing both account level information and revolving credit metrics. So let me try to zoom also a little more on the column names. So in our pipeline, basically data set include critical data driver like funded AM. You can see. So some variables are very important. This funded AM means the original loan amount. Then we have the total Rec P. What is that? Principal received. Then total REVH. What is that? Revolving credit limit. Then we have revolving balance. Okay, revolving balance is again very crucial. Then we have revolve utilization. So that is the utilization rate which we'll be importing in the SAS. Then we have debt to earning ratio of those customers who are there in the data. So this is very important. And a historical delinquency. From these raw figures, we calculate our target continuous variable, which is the EAD ratio. Okay. EAD ratio is very important. This basically represents actual dollar exposure divided by the total commitment by the customer, strictly bounded by 0 to 100% per regulatory guideline. So if you are working in credit risk and risk portfolio or SAS developer, today video is going to be like absolute gold for all of you for your resume. So we are going to break down a complete production ready EAD scorecard engine from the scratch using SAS. Okay, this isn't just a basic SAS code. It's built strictly according to the Basel III and IFRS 9 guideline standard, covering everything from the raw data processing to dynamic scorecard, point allocation, PSI stability calculation, and automate ODS governance reporting, so that validation, governance, everything is taken care. So grab your tea and coffee and just sit with me for next couple of minutes. Okay, now let me close the data and make sure you guys download the data because you will need it to run the code. Now let me go to the SAS code. So before you go to the Google, who don't have SAS in your system, and in Google type SAS University Edition, you will see this page like SAS OnDemand. You just go there. So if you're like me who already have an account on this, then I will click on access and it will open directly for me. But the people who are very new, okay, so you guys will not see your name on the right side like this. So you guys create account, sign up, put your details. It's very easy, no challenge. Once you will click on the launch, you will see this window where I have my code. Now all of you need to open the code which I will attach in this particular window, and to go to the full screen, just click anywhere and then F11 you need to press for this. Now guys, before I go to the code, first of all, we need to import that input data, right? Now that input data we will be importing in a folder. So if you will see on your left side, you will see something like this: folder, shortcut, and file. Now you go to the bottom and you will see output. You can import actually the input file anywhere, and then you need to pass that path. Now in my case, if you guys see, this is the path. Now I need to basically import the file at this location. So I'll right click on this one, upload file, choose file. It will go to the inputs. Here is my input file. I'll click on this EAD _model _dataset, open, upload. So it says that the file already do exist because I was running this code, checking the errors and everything before showing it to you. So I'll just click on replace. Right? Now the file has been imported into the SAS system. Okay. So basically, so to check that, I have pasted this part of code here. This is actually checking that if the file do exist or not. Now we have imported the file into the system, and you can simply check by extending this SAS version, like SAS user. Just click on this arrow. You see this arrow, right? Now, where is the file? It's on the top, which we just imported. This is the file. This is the imported file. Now go to the SAS. Let's come back. Just focus at this. So this green area in the SAS code is known as the job card. Basically, what job card tells: who was the developer when the code was developed, what is the description of the code, what are the standards it's following. So we are following the Basel III and IFRS 9 guidelines in this particular whole SAS code to calculate the EAD calculation, and we are making a EAD scorecard model. That is an important thing you all should remember now. Now, before I explain you the SAS code, just just remember that there are certain steps which are always you would be following. So, all right, on that note, we'll move to the step number 1 or the module number 1. So I have divided this SAS code into certain module. We'll talk module by module. Okay. Now, the module number 0 is all about global setup and infrastructure control, which is very important because we want to make our code reusable. So in enterprise production code, you never hard code physical path directly inside the script. Instead, we write SAS macro like setup environment, which you can see at your screen. Usually it automatically creates all the subfolders, server, input, output, logs, data, models, and assign permanent library to the whole code actually, which would be used by other developer in your team. So we also define our core scorecard scaling parameter right here. Okay. We usually do that in this step itself. So you can see the base score, all those value. So our target variable EAD ratio, base score is 600, base odd of 50, and point of double odds, which is also known as PDO, set to be 20. So if the source CSV file is missing, we even have a fallback dataset generated built in the script to run end to end without breaking. Now, that's what we have done by checking this. So in the initial steps only, step number 0, you will understand what are the variable, whether the file do exist or not. So the developer is not wasting time running the code. They will be able to crack this in the initial step only. Now, usually in the real life scenario, you will see each module is having one single code as a single code. So how usually SAS projects are stored, that in a single project you will see 10 codes for each individual module, but it's not like here because I'm trying to explain all the module one by one to all of you. So if I create one single SAS code for each module, that is going to be sometime confusing. But in the real world project, you will see the single SAS project which will be having multiple SAS programs. So this is the module number 0. Now, okay, on that note, moving to module number 1. So in module number 1, basically, we are first importing. We bring our portfolio data using the proc import. Here is a solid pro tip for your SAS interview. Notice how we explicitly set length loan is to $30 right at the data step. Why? Because this avoids downstream type mismatch and uninitialized variable warning, which we usually get as a SAS developer. So we then calculate our bounded target metrics, EAD ratio. Okay, that is going to be the EAD ratio, and obviously that is our target. Now, this EAD ratio, this represents the exposure at default as a ratio between 0 to 100. That's what the explanation which I already told you. Now in module number 2, if you see, module number 2 is all about performing automated data quality audits. We are using proc sort with no dupe key to basically extract duplicate customer ID into a audit table. And we actually enforce strict for logic to ensure that metrics like delinquency 2-year, which you can see, or DTI don't contain negative corrupt value, because this is going to make the data bias. So we try to avoid that. Okay. Now let's move on to the module number 3 and 4. So basically module number 3, 4 and 5 are actually EAD, imputation, and it's a combination of Winsorization. Now, module number 3 runs basic explanatory data analysis using proc summary. You guys can use proc means also, depending, every team is different, right? So in market, they use different methodology. Proc summary to check the basically distribution stats like mean, median, standard deviation, and you need to basically check all these values because these are the statistical quartiles things which you should know as a developer. Now in module number 4, I'm using a procedure called proc stdize. This is very important proc. Why? This checks missing value imputations. Instead of using a depreciated procedure, we use this particular procedure with method median reopen. This basically imputes missing value, numeric value specifically in place directly on a risk driver without dropping any non-numeric value like customer ID or target ratio, because that kind of situation creates the data loss for us as a developer. Now, module number 5. Guys, I am being very precise here, but this is the workflow which is getting used in the actual codes out there in the industry. You name any big bank, all of them are following the same approach. Now, module number 5, we address extreme outlier through the winsorization process. We extract the first and 99th percentile using the proc summary and cap variable like annual income, revolt utilization, and DTI, right? Why? Because we also try to create a log annual INC to normalize skewed income distribution, specifically for the regression modeling, because we are going to apply the strong regression model after this. So we should be having the complete end-to-end outlier capping, winsorization, EAD, and missing value imputation. Now in real world SAS code, sometime you will see that this is written in like 100 lines because that is the need of that particular project. In business teams, they will give you the logic and you need to implement this, but the steps and algorithm is going to be the same. If you know these procedures, you will be able to address their need. Now here comes the step number 6. Okay. Now this module number 6 handles the data partitions to basically prevent and basically target distribution skewed between the train and test data set. Because in every model, we have this train and test split. Some company have 70-30, some have 80-20. So we perform stratified sampling using proc service select at a 70-30 interval. Simple. You see this. This is the procedure which is the whole and soul of this step. So you guys can notice how we use this vval loan status to safely convert risk strata into basically standard character value regardless of underlying formatting. This is very important to remember, guys. This also guarantee smooth error-free stratification, which we are going to use for our model in the end. Now, the next step would be talking about the classing. Now, why this step number 7 is and then 8, even if I combine 8 bin metrics and step number 9, mean target mapper, all these steps have their own important aspects. Now, in credit risk, raw linear feature rarely capture non-linear relationship. So in module number 7 and 8, we perform fine classing and monotonic binning. We basically categorize utilization, DT, delinquency into risk band and then run our macro. Okay. This macro. Why? To compute mean EAD for every bin. Per every bin. That's what we are trying to achieve running after this macro. You can see, right? We are calling the macro for individual bins. Now, after this module number 9, we try to map these target encoded values. All these target encoded value, this and delinquency back into our primary training data set in the proc SQL. And this particular transformation basically discrete bin category into powerful numeric predictors. That's why this step number 7, 8, 9 combination is very important. Okay. Now let's talk about the next step, that is step number 11. Let's move on to step number 11. 10 and 11. Okay. My bad. Now step number 10. We basically run automated feature selection using LASSO regression. Just remember, you can see that, right? And via this proc GLM select with SBC criteria followed by proc correlation to check at the same time for collinearity across the predictors in our model. Then comes the heart of the pipeline, module number 11 basically. So we are applying the logistic regression. Obviously, the most important step, module number 11, regression estimation. We execute proc reg to fit our exposure model basically. We explicitly enable options like VIF, TOL, DW, and S spec to check for variance inflation factor. It's very important, guys. You need to check VIF value. Okay, so Durbin Wonston autocorrelation and heterocity. So we would be checking all this. This is why this regression model, this particular procedure is always very important. Without this, you cannot apply the regression model in SAS. Now, let's move on to the next module. And we'll run this SAS code once I tell you a little briefing about each module. I don't want you to get distracted like I run each module so that it sometimes get confusing. Right? Now in module number 12 and module number 13. So module number 12 and 13, we basically evaluate model has been built. We check even like the model is fitting properly or not. We extract basically raw residual, calculate absolute error, and summarize our standard regulatory risk metrics, RMSE. Root means square error, MAE mean square absolute error, and overall R square. That's what we are trying to achieve in these two steps. So model has been built. We have been checking the diagnostic and evaluation. Now we would be doing the dynamic scoring scaling in the step number 14. Now here is where the magic happens. Module number 14. In real world credit risk, the risk manager perform point-based scorecard. They don't care about the coding, right? They create the point-based scorecard in Excel at their own level. So these over raw decimal probability, they would be calculating those values. Using macro variables, we dynamically capture our regression coefficient, intercept, beta utilization, beta DTI directly from the dataset which we would be generating, EAD coefficient which we would be saving in the permanent library. Okay, we then apply classic logit scaling formula using factor and offset that you can see in this step. We are applying it here. Now, as I said, like we would be applying the formula using offset and factor to convert regression betas directly into easy to read customer points. This will give you the points. You will be able to see the points. In this, the output data set, you will be able to see those points. Now, next module, you have calculated points, everything is good. Now we will check the CCF engine and risk tier. In module number 15, basically, we compute actual exposure dollars and credit conversion factor, which is CCF. So we basically floor our predicted EAD ratio at 0% and cap them at 100%. Then we multiply by the funded commitment amount to get exact dollar exposure. For revolving line, we calculate the implied CCF against undrawn headroom. Okay, just remember that. Finally, we assign accounts into risk tier like low, medium, high, and flag any account over, let's say, $25,000 exposure and 75% predicted EAD ratio at a high exposure critical audit, because we have to satisfy that need also. Okay, in this particular step, that's what we are doing. Now in step number 16 and 17. So 16, you can see we are checking the decile rank ordering validation and then cumulative lift and exposure gain. So what we are doing in this, to validate rank ordering power, module number 16 using proc rank. You can see we are using proc rank to split the portfolio into 10 deciles sorted by the predicted EAD. Now in module number 17, we calculate cumulative exposure lift and gains. A strong model will clearly rank order exposure from higher EAD in decile 1 down to lowest EAD in decile 10. That is something you need to memorize. Let's talk about the next module, 18 and 19. So 18 is PSI, which checks the stability of the model. This is very important metrics from the model validation perspective. And 19 for checking the out of sample model. But step number 18 is more important. PSI is always on the top of all the banks in real world. If I name any of the multinational bank like JPMC, Wells, Citi, HSBC, even all of them, like they check population stability index always much more in detail when they talk about the model validation. Whatever you are developing as a developer, they would be always asking validation team to do PSI thoroughly. Okay, let's come back to the point. So this module number 18 and 19. Now for the model governance, module number 18 calculates the population stability. So we score our out of sample test set, bucket EAD ratio into standard bands, and compute PSI shift in the train and test distribution. If total PSI is under 0.10, our model is stable and safe for production deployment. That's what we do here. That's a generic standard which we follow, which I'm doing here as well. Okay, you can see in the band definition. Now in the step number 19. Step number 19 is more about summarize out of sample, generationalize overall by company train and test RSME and MAE side by side. That's what we do here. We are checking both those metrics side by side. That's why this is important. In some of the real world teams, you will not see this step because this is not a mandatory step again. Okay. Step number 18 is very important. It's mandatory also. Now module number 20. So we have completed, we have created the model, we have done some also testing, we have done the validation. Now what we are doing, we are checking the production macro and we are like preparing a final report, which we will be publishing in step number 21. That is as a PDF in the PDF form, because we usually send the file to the audit in PDF only. That is again a very important interview question I'm answering for you. Whenever somebody asks you in which form you give the reports to audit, never mention we give text file, word file. Always the bank gives PDF. Very well structured. Now in step number 20 and 21, in module number 21st, let's talk about that. Now we wrap our entire scoring logic into clean production batch macro. You can see the macro name is production EAD score batch. You can call this macro on any incoming quarterly portfolio to score raw accounts instantly. You don't need to do anything, just call this macro. Finally, the step number 21 is used to basically store the ODS output into PDF format. Okay, to generate a executive ready model risk governance audit report, it output our VIF diagnostic. That's why I was saying VIF is very important. It goes to the audit. Then it will be having the train and test accuracy, PSI stability metrics, and decile rank ordering directly into a clean PDF format. That's what we would be generating. That's the end goal of this whole project. Okay, now let me select this whole code, Control A, and run for all of you. You guys, I would suggest all of you to run the code one by one in module manner, because if I run the code module wise, that is going to be sometime confusing for some of you. But let me run the whole code. Click anywhere and then run. Since in our output, in the input data, we have only 1000 observations, so that's why it ran quite quickly, but it doesn't work in the real time manner. Okay, because when you will be in the bank, so you will be having like millions of observations, so this code will be running for hours. And also you always need to make sure that you check in the input how many observations are there. Okay, and in the output how many observations are there, and in the SAS log basically you can check all of that. Always read your SAS logs. You can see 3 warnings are something which we can ignore. That warning doesn't impact the output, error does. We have 0 error. Okay, so that's why it's important to know. Now in this whole code, in the output data, you will see so many data sets has been created. Okay, but the final data set which I want all of you to have a look at, that is in the output, and the final data set was customer EAD final. Let's click on that, customer EAD final, this one. So guys, now to understand this data set, the customer EAD final, because this is the ultimate data set Now let me go to the code. So I have a small piece here. I want to actually export that data set as a CSV file at this location to understand output much better. Okay. Now I'll just select this part. Let's run this. It has run successfully. So the file have been created here. Let's go in this folder. It should be in here. With the name of exported data.csv, but I cannot see it here. Why so? I think because the code has hit an error. Yeah. Export unsuccessful. Why? Customer EADF. So this is the correct name we used. Customer EADF. Let's go to the output and check the name of the dataset. If I think, okay. So the name of the dataset was customer EAD final. That's a misspell here, but we learn with these things, guys. Okay, just replace the name. Now this should run perfectly. Zero error. We missed the error last time. We don't need to do that. That is something we have to always make sure. Now we can go to the folder in the SAS 9.4 and you can see exported.csv is here. Now when I click on this, this will open the code, but what you need to do, just click on this and this pop-up window will come and then download file. Let's open the file. So this is the output we generated. Now to understand output a little bit better, let's see couple of IDs, right? Now let me take example. So guys, from the output file, I have removed all the other observation. I just kept two. So that let's discuss the output. Let's not get confused if I keep all those 1000. So there are two IDs. Okay. Now within a funded amount of 5000 for the first ID I'm talking, a total recurring principal is 457 US dollar. The actual exposure resulted in a EAD actual. We need to check the EAD actual. So EAD actual is 4,542 US dollar and a ratio. Let's check the ratio. EAD ratio is 90.85. The model predicted a predicted EAD ratio bounded. We need to check that predicted EAD ratio bounded. Predicted EAD ratio bounded. The value is 69.74. Yield a predicted EAD dollar of 3,487 and a CCF modeled of 45.37. Categorize a loan under which tier? Under a medium EAD exposure. That's the end goal. And you can see both of them are coming under the medium umbrella. Similarly to this, if I close this and just open the output again, since I deleted all the other value. So this is the full data. All the values are here. Now, if I go in the end and zoom it for all of you, you will see this column EAD risk tier. Now, this is the column which is required for all the repository where you would be reporting your data or the audit forums. So guys, this is how you build a full end-to-end enterprise grade EAD scorecard engine in SAS. This script covers every major requirement of a model validation, audit book also, and when you're looking for Basel III or IFRS guidelines, so this is complying all of that. So if you found this breakdown helpful, hit the like button and subscribe to my YouTube channel. Drop a comment if you want to know more than this or if you have a thought on whatever we have discussed. And on that note, I would like to take leave from all of you. But before that, I would say make sure all of you are downloading the file from the GitHub repository and the code and the input file. Okay, and just change the location because your location would be different for the input file. Okay, just change the location of the input file and then you will be able to successfully run this code. On that note, I'll see you in the next video. Thank you so much. All the best.
बहुत नीचा आदमी या तो नीचे धरती में